There are 18 million active freelancers competing on Upwork. In this environment, the most lucrative contracts do not stay open for days. A highly desirable job post will typically fill its initial interview slots within a 1 to 3 hour window. Crafting a highly relevant, deeply researched proposal manually takes an average of 10 to 20 minutes per application. When the optimal response window is measured in minutes, spending 20 minutes writing a single pitch means top-tier talent consistently loses out to faster, less qualified applicants. Securing initial client interviews is a mathematical optimization problem of speed and relevance, rather than a pure measure of professional skill. The obvious reaction to this time pressure is to open a generic conversational AI and generate a pitch instantly. Statistically, this fails. Unedited outputs from a raw language model achieve lower reply rates than proposals written entirely by hand. Standard language models lack contextual proof. They fall back on generic structural traps, relying on vague claims instead of hard, factual project metrics. UpworkScribe is an architectural solution built specifically to eliminate these generic outputs. To function effectively in a specialized marketplace, a product must abandon static text wrappers and implement a context-aware, retrieval-augmented generation system. Requiring a user to repeatedly paste their resume and project links into a prompt box creates massive friction. UpworkScribe bases its architecture on a profile graph. The system programmatically parses a user's existing public profile URL, extracting their history, job success score, and specialized skills in a single initial pass. It extracts specific metrics from past projects and stores up to 5 distinct labeled portfolio links. This persistent data layer anchors the AI. Every future generation pulls from this fixed database, utilizing accurate past work without requiring any further manual input. With the freelancer's historical data fixed, the system evaluates the active job posting. Using server-sent events, the software instantly streams dynamic intelligence to the user interface the exact moment a job description is pasted. It reads the raw job description and extracts specific software and domain requirements. The system cross-references these requirements. Tags colored green indicate direct profile matches, yellow indicates related skills, and gray highlights missing areas. Replicating the native platform interface informs the system of precise contextual gaps before any text is generated, establishing immediate user trust. The system's prompt architecture relies on a dataset of over 134,000 recorded proposals. This data applies strict mathematical penalties for standard professional habits. Including a scheduling link results in a 6.08 percentage point drop in reply rates, so the prompt explicitly forbids them. The data also identifies positive constraints. Framing past work with a from X to Y metric produces a 4.04 percentage point lift. Mandatory structural rules are injected universally. Ending a pitch with a specific question format to invite conversation is required, as the dataset proves it will guarantee a 5.89 percentage point lift. Effective system prompts use empirical data to mathematically box in the language model, eliminating hallucinations and forcing highly optimized outputs. At scale, a micro SaaS survives on its unit economics. The system categorizes client intent and selects between 5 distinct narrative frameworks, ranging from authoritative to consultative, before drafting. Google Gemini 2.0 Flash handles the primary routing. It executes these frameworks with sub-2-second latency at a fraction of a cent per generation. GPT-4o Mini acts as a fallback, reserved strictly for premium tier users who require highly nuanced personalization. This intelligent routing model balances a hyper-fast user experience with sustainable, scalable product margins. Generating a highly optimized piece of text gets the pitch out the door, but it is only half the life cycle of a defensible product. The analytics dashboard requires explicit outcome tracking. Users log whether a pitch resulted in a view, a reply, or a won contract. Tracking reply rates against specific structural frameworks and individual skill tags generates entirely new, proprietary data. This closed-loop system creates a compounding moat. The product iteratively learns what works for a specific user's exact market niche, auto-tuning future generations. Easily cloned AI tools only generate text. Defensible software products build deep, interconnected workflows. Defense requires 3 structural pillars: a persistent profile graph, strict statistical constraints, and a closed outcome loop. Integrating these three pillars transforms a generic API call into a specialized, native professional application. Ultimately, understanding the surrounding systems and data architecture is vastly more important than simply understanding the language model itself. The true value of an AI micro SaaS is never found in the prompt. It is found in the rigid data architecture built around it.